Today we're going to look at trigonometric substitutions, commonly known as trig subs. Trig subs allow us to simplify certain integrals containing radical expressions. You can see in this trigonometric substitution table different radical expressions with radicals and different substitutions that correspond to the different expressions. These substitutions allow us to simplify these expressions using these different trig identities. So it's helpful to try and remember these trig identities because they will help you know which substitution to make in different cases. All right, so say we're given the indefinite integral of the square root of x squared plus 16 over x to the fourth dx. So what we'll want to do is kind of look back at this trig sub table. This expression is this same expression here. So what we're going to use is we're going to use x is equal to a tangent theta as our substitution. So here we'll have x is equal, in this case our a, here we have 16, so the square root of 16 is 4, so our a will be 4. So x equals 4 tangent theta. And for convenience, I will write down this identity so we can have it here with us. So we have 1 plus tangent squared theta is equal to secant squared theta. All right, so we'll set this table aside. Okay, so we have this substitution. So we have something that we can substitute for x, but now we need to find something to substitute for dx. We often call this the differential, and what that means is we're just going to take the derivative of our substitution. So we will have dx is equal to 4 secant squared theta d theta. And for those of you who have gone on to Calc 3 and you're just coming back and looking at this for a review, this is also the Jacobian. So now let's make these substitutions. All right, so we have the indefinite integral of the square root of 4 tangent theta squared plus 16 all over 4 tangent theta to the fourth. Now we have our substitution for dx here. So this is all multiplied by 4 secant squared theta d theta. Awesome. So I hope these colors can help you see where all these substitutions are going. And what I'm going to do from now on, I'm just going to use the same color. All right, so let's work on simplifying these expressions. So we have the indefinite integral of the square root of 16 tangent squared theta plus 16 all over 4 to the fourth is 256, so 256 tangent fourth theta 4 secant squared theta d theta. All right, so from here we can factor out this 16 under the radical. That will leave us 16 times tangent squared theta plus 1 all over 256 tangent fourth theta, 4 secant squared theta d theta. All right, so here we can see, this is awesome, we have our identity right here. So we can make that substitution here. So we have the indefinite integral of 16 times secant squared theta all over 256 tangent to the fourth theta, 4 secant squared theta d theta. All right, so can you see how nice this makes this radical? Because they're being multiplied together and they both have a perfect square root, what we're able to do is simplify this even more. So we have the indefinite integral of 4 secant theta over 256 tangent to fourth theta times 4 secant squared theta d theta. All right, now what we can do is combine these secant squares and these. I'm going to pull out this 4, so this would be 16 over 256, which is the same as 1/16. So I'm going to pull that out. So then we're left with 1/16 of the indefinite integral of secant cubed theta all over tangent to the fourth theta d theta. So that makes this a little bit simpler. All right, now what we can do is we can rewrite secant and tangent in terms of sine and cosine and simplify from there. So we have 1/16 of the indefinite integral. So secant is 1 over cosine. So we have 1 over cosine cubed theta over sine to the fourth theta over cosine to the fourth theta d theta. So what we do from here, because we are dividing, we have a fraction and we're dividing from another fraction, what we'll have to do is multiply by the reciprocal. Some of you may know this as copy dot flip. So we have 1 over 16 times the indefinite integral of cosine cubed theta times cosine to the fourth theta over sine to the fourth theta d theta. All right, as you can see, this makes it really easy because we're able to cancel out cosine 3 to the third, which then leaves us with 1 cosine on top. So this now gives us 1 over 16 of the indefinite integral of cosine theta over sine to the fourth theta d theta. Okay, now from here, what we can do is a u substitution. All right, so I'm going to rewrite this up here. All right, so let's do our u substitution. We'll let u equal sine theta. So because we're changing our variables, just like we had a differential here, we're going to have a differential here. So that's why we take du is equal to cosine theta d theta. Alrighty, so let's make this substitution here. So we have 1 over 16 indefinite integral of, we see that du is equal to cosine of d theta, which we have right there. So that eliminates that cosine here. So we will just be left with 1 over u to the fourth du. All right, and I like to rewrite this as 1 over 16th indefinite integral of u to the negative fourth du. I feel like when I change it to this power, it makes it a lot easier to go about anti-deriving this. Okay, so we have 1 over 16 So now the antiderivative of this, we raise the power by 1, so we have u to the negative 3, and divide by that new power. So divide by negative 3. And then we'll have this plus c here. All right, so what we can do is now substitute sine back in for u. So now we will have 1 over 16 times sine to the negative 3 theta over negative 3 plus c. All right, so let's simplify this a little bit more here. So we can multiply the negative 3 and the 16 together. So we will get negative 1 over 48. And we can simplify this sine as well, which will be 1 over sine cubed theta plus c, which that is the same thing as cosecant. 1 over sine is cosecant. So let's make that change. So we have 1 over cosecant cubed theta plus c. All right. So we have negative 1 over 48 times cosecant cubed theta plus c. However, now we have this in terms of theta, but we started out in x. So what we're going to want to do is get this theta in terms of x. And how we can do that is by drawing a triangle. So we have our triangle here. And what we'll want to use is our trig sub that we used. So we have x is equal to 4 tangent theta. So let's solve for theta so we can kind of figure out these different sides, right? So tangent theta is going to equal x over 4, and tangent is opposite over adjacent. So the x is going to be here, 4 is going to be here, and this is going to be x squared plus 16, which is what we substituted for. All right, so we want cosecant, which is the opposite of sine, and sine is opposite over hypotenuse, so cosecant is going to be hypotenuse over opposite. So let's make that change. So we have negative 1 over 48 times, so hypotenuse is the square root of x squared plus 16 over opposite, which is x, and this is going to be cubed. All right, and if you wanted, you could further simplify this to be negative 1 over 48 times x squared plus 16th to the 3/2 over x cubed plus c. But there you have it. That is how you go through and do trig subs. So as we can see, the trig subs made things a lot easier to solve. So here are things to remember. When changing the variables, we need to include a substitution for dx, like we did here. And also, important point is to memorize these identities. Memorizing these identities are going to help you be able to remember which substitution to make in each different expression. And then finally, use the triangle to change theta in terms of x. So we need to use this triangle here to make sure we get back in terms of x, because that's what we were asked. We weren't asked in terms of theta. We just made that substitution to be able to solve, so we need to put it in terms of x. All right, I hope you enjoyed this video, and I hope it's helpful, and good luck with your trig substitutions.